Okay. Step 6 is turn lone pairs into bonding pairs. And I don't know that I've got this on there, but the number of bonding pairs that you erased will be the number of lone pairs that you have to turn into multiple bonds. Okay. And then finally, step 7, if it is an ion, put brackets and a charge. So that's why if it's the same number and you go to step 7, basically, if it's not an ion, you're done in step 4. If your count and check checks out, you're all done. Well, it is, and then it isn't all of a sudden. So let's say I gave you H2C, yeah. CH2O. Now, first of all, we need to find our valence electrons. And so I have 1 carbon times how many valence electrons? 4, so that's 4. I have hydrogen, which has a 2, so that's 2 times 1 is equal to 2. And I have oxygen, which has how many valence electrons? 6. If you don't know the number of valence electrons, where do you look? The group number tells you the number of valence electrons. So carbon is group 14, so it has 4 valence electrons. Hydrogen is group 1, so it has 1. If you're in the teens, you can just ignore the 1. Okay, so oxygen is group 16, it has 6 valence electrons. Okay, so now we have 4 plus 2 plus 6 gives us 12 valence electrons. What do we do next? Skeleton. Who should go in the middle of our skeleton structure? Carbon. Okay? And when you have a choice, make it as symmetrical as possible. Where should we put things? Yeah, so you can put the hydrogen off to the right and the left, and then the oxygen you can either put up or you can put it below, whichever way you prefer. Do you have a preference? That's fine. Yeah? Yep. Yep. There are ways of figuring it out, but they require you to have a bigger facility with like just knowing how things fit together, right? Okay, so for now, just make the most symmetrical thing you can. Okay. All right. So that is our step 2, is that skeleton structure. And for anyone who is away, a skeleton structure, we just basically make the most symmetrical thing and we attach them by lines. Each line equals how many electrons? That's 2 electrons because a line represents a bond, okay? Now we are going to add lone pairs. Until everybody has 8, or it's one of the exceptions and it needs either 2, 4, or 6, okay? So who needs extra electrons? Does carbon need extra electrons? Yes, how many does carbon have right now? 2, 4, 6, because it's got the bonding pairs all around it, 2, 4, 6. So it needs an extra 2. Who else needs more? Oxygen. Oxygen has how many right now? It has 2 because it has this bonding pair of electrons, and that's 2 electrons, okay? And now we are going to add 6 more, 2 on each side, 2, 4, 6. Remember, your electrons always have to come in pairs when you are drawing Lewis structures of covalent compounds, okay? All right, now we're going to, what is step 4? Count and check. So there's several ways of counting and checking. You can say I have 3 lines. Each line is 2 electrons. So that's 3 times 2 electrons gives me 6. I have 1, 2, 3, 4 lone pairs, which is 4 times 2 electrons, which gives me 8 electrons for a grand total of 14. If you prefer to just put your finger on them and like, you know, touch them and go, I've got, if you just prefer to go, I've got 2, 4, 6, 8, 10, 12, 14, that's fine as long as you don't lose track. You know what? Because sometimes the structure is kind of big and you're like, did I count those ones already? Shoot! Which is sometimes why I like to do it this way, but either way is good. Are these the same? They are not the same. I have 1 pair of electrons too many. And if I have 1 pair too many, that means I'm going to need to erase 1 pair and form 1 multiple bond. Okay? So we go. I'm just going to redraw my structure down here. All right. So who am I going to remove electrons from? The C, because I'm going to erase electrons from the central atom when possible. Okay? Then you just remove it from whatever looks best after that. Okay? There is a little bit of art to this. Okay? Now, You now need to, now how many electrons does carbon have at this point? 2, 4, 6. Carbon needs to have 8. So we're going to say oxygen is going to be super kind. Oxygen is going to say, I will give 2 electrons and turn those into a bond so that I can have them and carbon can have them as well. So instead of having a single bond there, I'm going to have a double bond with that pair I just moved in. Oxygen, carbon, is good. Now, this is a perfectly good structure. If you're into this kind of thing, you could, if you wanted to, say, I know that electrons don't like to be near each other, so it would actually be most correct if I drew my lone pairs like this so that they are all as far from one another as possible. But that's like an extra level. So don't worry about that. I would not mark you on that. You can put them on the side and on the bottom. You can put them on the side and the side. You can put them on the other side and the bottom. Or, what's that? This is a polar molecule, yes. Yes. Bam. Yes. Beautiful. Okay. Let's try another one here. Let's try BH3. Do you guys want to try that one on your own? Yeah? You want me to do it? Okay. Step number 1, valence electrons. Boron is in group 13. Therefore, it has 3 valence electrons. It is really easy. Hydrogen is in group 1. Therefore, it has 1 valence electron. So in total, I have, oops, there's 3 of them. So that is also 3 valence electrons. So in total, we have 6 valence electrons. Okay, hydrogen and B ball. B ball. So it goes 2, 4, 6. 2, 4, 6. Yep. Not at all. Apparently, the original number is not 666, it's 661 or something like that. I can't remember. But anyway, the whole thing about 666, it was like from a movie or something like that. Anyway, so we now have, we're going to draw our skeleton structure B, H, H, H. And now we say to ourselves, add our lone pairs. Does anybody need lone pairs? No, because hydrogen already has 2 and boron already has 6. It is an exception to the rule, so it doesn't need a lone pair. And now we're going to count and check. I have 3 lines, so that's 6 electrons. 3 times. Oh my gosh, how hard was that one? I know, right? So hard. Bibble. Now look what I've done. What have I added in for you? So this looks trickier, right? Because we've got that positive sign. So we're going to say I've got nitrogen, which has, I've got one of them. It's in group 15. So how many valence electrons? 5, because it's in group 15. Okay. So that's 5 valence electrons. I have 4 hydrogen. Whoops. So that's going to be 4 times 1, which gives me 4 valence electrons. And now what do I do with this charge? I have a plus charge. We will do that later, but it does tell me something about the number of electrons. It tells me that I am lacking 1 electron, right? Because if I'm positive, I'm missing some negative, right? The only thing I can add and subtract are electrons, so there must be a missing electron. So with a positive charge, we are going to subtract 1 valence electron. So for a positive charge, you subtract electrons. If you have a negative charge, you add electrons. Okay? So we look at this and we go, okay, that's great. I have 9, but now I'm taking away 1, and that gives me 8 valence electrons. Who's going to go in the center? Nitrogen. Where do the hydrogens go? 1 on every side, top, bottom, left, and right. That is a polyatomic ion. Does anyone know its name? Ammonium. Ammonium. Now, there's lots of negative ones. There's only 2 positive ones. Now we count and check. How many electrons do we have in this structure? 2, 4, 6, 8. Is good? Wow, I have 8 electrons. Did I want 8 electrons? Yes, I did. So in theory, we're done, right? Or have I forgotten something? A bracket and a charge. Yes, bracket and a charge. Okay, so don't forget the bracket and the charge. All right. Do you want to try that one on your own? It's a little bit more challenging. If you need spare paper, there's some at the back, don't forget, okay? And if you're like, I'd like a little help, wave me over. And then like, these are not the same examples I've been doing, but if you want a whole bunch of examples, like you can be like, oh, here's CH3I, and it follows all the way through. And here's CC, and it follows all the way through. So if you're like, okay, Ms. Spence, your examples are not enough, there's many more. Okay, and then this, although this is in your book on page 6, and there's like an expanded version on the back, this is just handy to have in front of you to remind you of the steps when you're first starting. Yeah. It's okay. Like honestly, it doesn't you don't necessarily have to do it this way, but it does prevent like most people from making stupid errors. Yeah. Yes. And that's why I've switched to the method where you draw them all and then you erase them, because now you're like, oh, I know how many lone pairs, I know how many multiple bonds I need to make. And I never used to do it that way, and then I saw someone do it and I'm like, oh, that prevents mistakes. I like that. Yeah, exactly. Of course. So hopefully by this point you guys have figured out that we have 24 valence electrons. If you didn't get 24, call me over, I'll help you out. And the skeleton structure should look like this. All right, so if you got that far, you're like halfway there. That's just the skeleton structure, we're not done yet. So hopefully, if you got your skeleton structure, you drew all the lone pairs on it so it looked like that, so that there's something on the top and the bottom and each side of each atom, because there's no weird ones that have less than 8. Everybody here has 8. And now I'm counting them up. 10 lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3 lines. So that's going to be 10 times 2 is 20 electrons, and I have 3 times 2 is 26 electrons. And then I look and I say, are these the same? No. I have one pair too many. And if I have one pair too many, how many pairs am I going to erase? Therefore, I'm going to erase one pair. Who am I going to erase it from? From the central atom, from nitrogen. And I am also going to then form one multiple bond. So if you're keeping track, if I have one pair too many, that means I erase one pair and I form one multiple bond. Okay, the pairs you erase tell you how many multiple bonds you need to form. Okay, which is kind of the beauty of this technique. So from my structure, I'm not actually going to erase, I'm going to redraw, but you can just erase if you want to. And I've erased this pair right here. Now I need to form a multiple bond. Okay? So somebody needs to share. It can be any one of the oxygens, it doesn't matter which one. Okay? I'm going to pick this one because it's closest to me. And I'm going to move it in here. So it stops being a lone pair and instead it becomes a bonding pair. So between that oxygen and that nitrogen, we now have a double bond, which is 4 electrons, 2 in the red one and 2 in the black one. And if I've moved these ones out, they're no longer there. I just have these left and those left. And I haven't done anything to anybody else, so they just all stay the same. And now let's look at our structure and check everything out and make sure that we're good. Okay? Do we have 24 electrons, which is how many we need? We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24 electrons, yes. So that's check number 1. Check number 2, what you want to do is and this is where I miss being able to just cover it up on the page. So pretend you can't see anything from here on over. Just pretend, like, oh, can I do this? Hang on. Oh, there we go. Look at that. Count the pairs around the oxygen. 2, 4, so we have 2 lone pairs and 2 bonding pairs makes 8. Okay, here we go. Let's try this. All right, hang on. Now we're going to look at nitrogen. And I can't block off the other oxygen. You're going to have to pretend because I only have 2 hands. How many pairs are around the nitrogen? 4 bonding pairs. Yay! Is that what we want? Yes. And I can't do it. I'm not tall enough to do that. I have a step stool here somewhere. I could, but it's just as much work for me to grab this. Okay. How many in that oxygen? 3 lone pairs. 1, 2, 3, and a bonding pair. Yes? And over on that oxygen, same thing, 3 lone pairs and a bonding pair. So you always want 4 pairs of electrons around each atom, unless it's one of the exceptions. How are we feeling about it? You won't have singles. You shouldn't have singles. If you have a single, the only time you should have a single is, let me see. Do I have a singleton electron section in here? Group H. The only time you should end up with a single electron is in group H. But you guys could now do, and Sam, there is a answer key for this. If you're having trouble, bring your answer key up and I'll show you where. Okay? So on page 98, you can do number 4, 5, and 6. So that's group A again. Those should be the easiest. Okay. How about we do number 7, 8, and 9? And 16, 17, 18. Oh, and oh my God. I forgot my brackets in my charge. Oh, I fail. If you cannot get them all done, at least do 1 or 2 from each set. Like if you're like, I don't have as much time tonight, I'll maybe do some of them later. This is set A. This is set B. And this is set C. So carbon can form 4 bonds, so it's in the center. So whichever one can form the most bonds is in the center. But the electrons are allowed to go anywhere in here. Okay, so once we start sharing them, they don't belong to one atom anymore, they belong to more than one atom. Oh. Yeah? Yeah. Yeah. Anyone want to know about resonance structures? Maybe not today. Next day, maybe. Save something for tomorrow. Here? And just so you guys know, the answer key for this, I've literally shown you every step, right? I've written step 1 and I've written the valence electrons. I've done step 2 and I've drawn the skeleton structure. So if you're getting stuck, do look at the answer key because it literally has every step worked out for you. Okay? Whew. It's 2, 2, 2. Yeah. Every bond, every lone pair is just 2 electrons always. Yep. Why do I have so many of these? What's wrong with these? That's a lot.
That hits.
I'm sorry, I forgot to number the answer key this time. I don't know. But all the worksheet numbers are at the top, so you should still get it.
Oh, Alvin. I am playing with credit integrated.